Hello, good afternoon, boys and girls. Good afternoon. Give me the clearance, please. Am I audible and visible? I hope I am audible and visible, boys and girls. Just give me the clearance. Hello, good afternoon. Yes, okay, good evening. Thank you. Mon Para, thank you very much. So, very good afternoon to all of you. Welcome to Unacademy. Dr. Khalil Khan here, welcoming you to Operating System नया आगाज सीरीज. आज का हमारा 14th लेक्चर है इन प्रोसेस सिंक्रोनाइजेशन. इन द अर्लियर सेशन हमने देखा विथ रिगार्ड टू सेमाफोर्स और आज हम कंटिन्यू करेंगे सेमाफोर और उसके बाद वी विल डिस्कस द एप्लीकेशंस ऑफ सेमाफोर्स इन द फॉर्म ऑफ क्लासिकल आईपीसी प्रॉब्लम्स, जो काफ़ी इंपॉर्टेंट टॉपिक है. Yes, Karan Anand, it is definitely possible. 6 months क्या 3 months में भी I have seen people cracking gate. Karan Anand, जरूर कर सकते हो. 3-4 months के प्रिपरेशन से भी मैंने देखा है अपने एक्सपीरियंस में people cracking gate. Okay, I hope you got my point, Karan Anand. So boys and girls, let's continue. This is my official Telegram channel again. Those of you who have not joined can think of joining for various purposes and benefits. And earlier session में हमने देखा semaphore is one of the operating system primitive जो has been designed as a general purpose utility and essentially implemented as an ADT, abstract data type, user defined data type you can say, and that support two indivisible atomic operations जिसका नाम है down and up या फिर आप कहो wait and signal. And essentially initially it was named by 𝐂𝐤𝐬𝐿 by name P and V. तो initially semaphore के operations का नाम था P and V. Later it was renamed as wait and signal, and definitely it is also called down and up. Yes, Karan Anand, it is absolutely possible. Double digit rank आप within 100 ला सकते हो within 4 months. I'm not bluffing, I'm not trying to boast. It is quite possible always. I have seen based on my experience of gate journey. It is always possible. Chaliye. So boys and girls, I would like to re-emphasize here that semaphore operations can be implemented in 2 ways. Yes, last class we have discussed. Semaphore operations can be implemented in 2 ways. One is busy waiting based and the other is non-busy waiting. Non-busy waiting. Busy waiting based is also called spin lock, and non-busy waiting based is also called blocking. जो traditional implementation है वो non-busy waiting wait, but however this is an old implementation. This is not a desirable one. Just for the purpose of definitive purpose, we have this busy waiting based solution, which is outdated, not considered for implementation. But however, चूंकि लिटरेचर में है इसलिए हम पढ़ते हैं. So you should also be knowledgeable with regard to busy waiting based. So here you can see the wait operation जो पिछले क्लास में हमने देखा था. Any process desiring to access critical section or desiring to access the resource will have to perform wait operation जिसमें process will check the value of s. If s is less than or equal to 0, busy wait. तो यहाँ पर मैंने कहना है आपको, जो पिछली क्लास में भी मैंने आपको कहा था, वो काफी इंपॉर्टेंट पॉइंट है, वो ये है कि दिस इज एटॉमिक कंपैरिजन एंड फिर सब्सिक्वेंटली डिक्रीमेंटिंग द वैल्यू ऑफ s. अदरवाइज अगर आप नॉन एटॉमिक इन जनरल सेंस में यूजर मोड में एग्जीक्यूट करोगे then decrementing the value of s will be done in a preemptive mode. Quite possible है, लेकिन semaphore में गारंटी होगी कि these two operations will be done atomically, because comparing the value of s with 0 will involve several operations, several instructions. Like you load the value of s, you compare it with 0 and accordingly take action. 3 instructions तो minimum होंगे. तो in a normal sense it is possible वहां पे preemption हो सकता है और preemption may lead to inconsistency. So to avoid that inconsistency, we guarantee atomicity on this operation and atomicity on this. So as such, the whole operation will not be atomic like as people may think. The comparison operation and the decrement operation will be atomic. And similarly here, incrementing the value of s by 1, is also done atomically. Ye hai meaning of atomic. So any process, if it find that the current value of semaphore is less than or equal to 0, it will busy wait. We say it is unsuccessful. Otherwise, it will decrement the value of s. मतलब simple ये है कि अगर semaphore की value positive हो, like semaphore value is 3, तो मतलब 3 times it will be successful in decrementing the current value. 3 to 1, 2 to 1, 2 times basically. And third time it gets stuck. जैसे ही value of semaphore becomes 0, it will get stuck in that loop. ये है basic wait operation in busy waiting based. उसी तरह non-busy waiting based, busy waiting based up operation is simply incrementing the value of semaphore by 1. Agar value of semaphore is 1, value of semaphore is 0, it will get incremented by 1. So that we say next time it will be successful. तो ये है busy waiting based. Busy waiting based में हमने देखा था कि processes will have wastage of CPU time. So for that reason, in most of the practical implementations of operating system, semaphore operations are implemented in non-busy waiting based. तो उसके लिए first we have to define semaphore as a abstract data type. Rishi, that is correct. Now Rishi, what you have to remember, it will decrease the value of semaphore by 1 provided the value of semaphore is greater than 0. सुनिएगा Rishi, provided the value is greater than 0. अगर equal to 0 हो, less than 0 हो, तो it will get stuck in the loop. It will get stuck in the loop. So for non-busy waiting mechanism या blocking mechanism में semaphore is implemented through an abstract data type. That means आपको create करना होगा structure या class. So either you can implement through a structure or through a class. हमने देखा था पिछले सेशन में कि we have basically implemented in the form of a structure. So type def struct value will hold the current value, and then you have the list of PCBs of those processes that will get blocked while performing down operation. और ये है basic operation of semaphore. Like again, decrementing the value is atomic, check comparison is atomic, and then this operation of course is atomic because this is purely done in kernel mode. क्योंकि PCBs जब ऐड करोगे आप लिस्ट में वो ऑपरेटिंग सिस्टम डेटा स्ट्रक्चर होगा, तो therefore it will be done in the kernel mode always, and then the block operation will cause the process to go from running state to block state. ये है block operation. So semaphore operation, down operation जब आप perform करोगे non-busy waiting based, the current value of semaphore is decremented by 1. If the resultant value become less than 0, look at this, less than 0, then we say the process is unsuccessful, it will get blocked. So it will release the CPU and get blocked. Another process, and the mode will come back to user mode, and then the other processes can continue. That is the philosophy of down operation. उसी तरह up operation में क्या होगा? Current value of semaphore is incremented by 1, and if the resultant value is less than or equal to 0, then it means that there are some block processes. And in that case we have to select one of the processes from the block queue and wake it up. तो उसके लिए हम यहाँ पर wake up operation perform करेंगे for wake up operation. Typically बच्चों यहाँ पर आपको कहना ये है कि अगर ये depending on the queue जो है, ये जो list है, the list of PCBs जो है, जो list है, this list can be implemented. It is essentially a queue. So this can be implemented either in a FIFO discipline or following a LIFO discipline, or maybe I can have other discipline also like priority. तो मैं आपको कहना ये है कि if it is implemented in FIFO discipline, then it is starvation free. ये बात याद रख लीजिए, starvation free. Otherwise, if it is implemented in LIFO or other discipline like priority, etc., that means the list of PCBs in the form of a queue, अगर implemented होगी with regard to LIFO or with regard to priority queue, then it will be subjected to suffer from starvation. ये point बहुत ज़्यादा important है, आपने याद रखना है, starvation. And subsequently, I would like to tell you that क्योंकि starvation free है, that is why we call this semaphore as strong semaphore. This semaphores will be called strong semaphore, and if it is subjecting to suffer from starvation, it will be termed as weak semaphore. This is another way of categorizing semaphore. Apart from semaphores being called as counting and binary, semaphores can also be called as strong and weak, depending on the implementation of the queue. So that is another perception with regard to semaphore operations. और हमने पिछले क्लास में देखा था कि basically how semaphore can be used for solving critical section problem through down and up operation. लेकिन semaphores के there are some problems also. I have some problems also associated with semaphores. What are they? So boys and girls, improper usage of semaphore operations could lead to potentially deadlock, improper operations, or it may lead to dissatisfaction of mutual exclusion. Like for example, यहाँ पे दिया गया देखिएगा, incorrect use of semaphore operations. Like for example, अगर critical section है, let's imagine this situation. ये critical section है, and I have an entry section here, and exit section. तो हमें पता है कि traditionally, when you want to guarantee mutual exclusion, when you want to satisfy mutual exclusion, entry section में हमने down operation perform करना है और exit section में we have to perform up operation. That is the norm. लेकिन by mistake, it may be mistake of programmer, it may be mistake of user. By mistake, in the entry section, if we perform up on mutex is a binary semaphore or counting semaphore, and if we perform down operation on mutex, by mistake, if somebody write the code like this, that is what is the first problem trying to say, then eventually what is going to happen? Then in that case, mutual exclusion will fail. Every process will be successful in performing up because no process will get blocked while performing up operation. Important point है note करने के लिए. A process never get blocked while performing up operation. कोई भी process यहाँ पर up operation perform करेगा, it will be successful and enter critical section. तो मतलब सारे processes जा सकते हैं critical section में, मतलब mutual exclusion fails. So therefore, improper usage, improper ordering of semaphore operations will lead to basically dissatisfaction of mutual exclusion. So the correct order is wait on mutex and signal of mutex. Okay? या बात जगह ऐसा हो सकता है कि दो जगह भी अगर आप at two places, for example, यहाँ पर भी आपने by mistake p of mutex, यहाँ पर भी p of mutex. This could also lead to problem. एक बार एक प्रोसेस एंटर होगा क्रिटिकल सेक्शन में, उसके बाद नोबडी कैन एंटर क्रिटिकल सेक्शन, क्योंकि यहां पर आप अनब्लॉक नहीं कर रहे हो, यू आर नॉट रिलीजिंग द सेमाफोर, यू आर अगेन परफॉर्मिंग डाउन ऑफ म्यूटेक्स, सो दैट विल आल्सो लीड टू प्रॉब्लम. ऋषि इज आस्किंग एमएसक्यू में प्रॉब्लम हो रहा है सर, उसके लिए देखिए बेटा ऋषि, द बेस्ट पॉसिबल वे ऑफ स्ट्रेंथनिंग एमएसक्यू प्रॉब्लम सॉल्विंग प्रॉब्लम्स ऑफ एमएसक्यू टाइप इज यू नीड टू हैव वेरी स्ट्रॉन्ग फाउंडेशंस एंड कॉन्सेप्ट्स. थियरी आपकी जो है, थियोरेटिकल नॉलेज जो है वो स्ट्रांग होना चाहिए, कॉन्सेप्ट बिल्डिंग आपकी वेरी स्ट्रांग होना चाहिए, तभी आप एमएसक्यू टाइप ऑफ क्वेश्चंस अच्छे तरीके से वर्क कर सकते हो. एंड यू ट्राई टू बेसिकली वर्कआउट ऑल पीवाईक्यूज जिसमें एमएसक्यू टाइप क्वेश्चंस की पोटेंशियल पॉसिबिलिटी हो सकती है, सो दैट यू कैन गेट एन आइडिया कि हाउ एन एमसीक्यू क्वेश्चन इन सम केसेस कैन बी कन्वर्टेड टू एमएसक्यू. सो डू द प्रैक्टिस, कंटिन्यूअस रिवीजन रखिएगा अपने, और पूरे कॉन्सेप्ट प्रोफाउंड अंडरस्टैंडिंग रखिए. आई एम वेरी श्योर यू कैन वर्कआउट MSQ questions with ease. तो ये है बच्चों ये. And the other example, other problem is incorrect usage. जैसे कि for example, imagine I have binary semaphores. Let us define binary semaphores by name SX equal to 1, SY is equal to 1, two binary semaphores. And let's imagine that I have two processes. Let's name it process I. Suppose if it is performing down on SX followed by down on SY. And then I have other part of code, I don't care. And there is another process PRJ. There is another process PRJ. Suppose if it is performing down on SY and then down on SX. Okay? And then it performs the other code. So boys and girls, I would like to have your attention here towards this aspect. You can imagine these are the entry sections of both PI and PJ. So what is going to happen if I write the code in this fashion? पहले process PRI will perform down on SX success. उसके बाद अगर preempt हो गया process, it got preempted, then it performed down on SY. Now both SX and SY are 0. उसके बाद eventually क्या होगा? the second process will get blocked at sy, first process will get blocked at sy, second process will get blocked at sx, because both sy and sx are 0. So this situation eventually lead to deadlock. So कहने का मतलब ये है कि improper usage of semaphore operations, semaphore operations अगर सही ऑर्डर में यूज नहीं किए गए, it will definitely lead to deadlock. ये responsibility आपकी होगी, इसके लिए आप semaphore को blame नहीं कर सकते. Absolutely semaphore operation में कोई problem नहीं है, semaphore operation is flawless. ठीक है? So this is not, you cannot say this is a problem of semaphore operation. नहीं बेटा, this is not the problem of semaphore operation. This is the problem of the user or the implementer जिसने semaphore operations को सही ऑर्डर में नहीं लिया. ये एक प्रॉब्लम है semaphore का. If the semaphore operations are not activated, not used in proper order, potentially it could lead to problems like dissatisfaction of mutual exclusion, or maybe, leading to deadlock like situations like this. So these aspects you have to be careful while designing applications using semaphores. Okay? So that is about the detailed discussion that we had with regard to what do you say, semaphores. Okay? We have seen binary semaphore and counting semaphore, both of them. Entry and exit placing having only wait. Then I told Rishi, suppose if both the places I have, imagine down, I will take a situation and analyze what Rishi is asking. Let's say we have a binary semaphore. I'm naming binary semaphore like this: binary semaphore mutex is equal to 1. Okay? And in the entry section, we are performing down of mutex. And then I have critical section. And again I have down of mutex. अब देखिएगा क्या होगा. It's an interesting situation. So please observe. If I have wait of mutex, critical section, wait of mutex. Rishi, I would like to have your attention. Check as you ask the doubt. तो सबसे पहले imagine, for example, process I will start. Process I. वो क्या करेगा? Down of mutex. Mutex becomes 0, success. Critical section में जाएगा process PI. And then after completing critical section, क्या होगा? Down of mutex. PRI will get blocked here because the value of semaphore is 0. So process I will get blocked. जब process I block होगा, process J will come. It will perform down of mutex. Mutex is 0. Process J will get blocked here. Then process K will get blocked here. So all other remaining processes will get blocked. सभी के सभी, सारे के सारे processes get blocked होंगे. तो मतलब ये हुआ कि सिर्फ एक ही process critical section में first time enter हो पाएगा. उसके बाद no process can enter critical section. Eventually a sort of deadlock like situation would arise. Nobody can go to critical section now after the entry and exit of one process or the first process. Am I clear, Rishi? बात समझ में आ गई? What is going to happen if I have at both the places down of wait of mutex and wait of mutex? Am I clear? So ये problem हो सकता है. So वही बात मैंने reiterate की थी कि while using semaphore operations in the application, typically you have to be extremely clear with the order और कौन सा operation use करना पड़ेगा for solving the problem of critical section or the required problem of synchronization. तो ये है semaphore operation. So we have seen binary semaphore and counting semaphore, both of them. दोनों में difference ये है कि binary semaphore can take only two values, 0 and 1, and counting semaphore can take any negative value, any positive value. ठीक है? तो binary semaphore is a subset of counting in the sense that जो भी application of binary semaphore से implement कर सकते हो, वो आप counting semaphore से भी implement कर सकते हो. और अगर मैं ये भी बात कहूँ कि if the system is implementing only binary semaphore, then using binary semaphore you can implement counting semaphore also. So if you want to see that implementation, आप Galvin की textbook देख सकते हो. ठीक है? So these are the essentials of semaphores. Elements of semaphores, operations of semaphores. So if you are basically confident of semaphore operation, तभी आप application देख सकते हो. So one of the prominent application जहां पर semaphore use होते हैं, एक तो है critical section, solving critical section problem. दूसरे कई other problems also can be solved using semaphores. Like एक और एक simple example दूंगा before I come to the actual topic of today's session, जहां पर मेरा intention है discuss करना क्लासिकल आईपीसी प्रॉब्लम्स. उससे पहले एक और आपको एप्लीकेशन बताता चलूं जहां पर आप काउंटिंग सेमाफोर से कैसे प्रॉब्लम सॉल्व कर सकते हो इन ए डिस्ट्रीब्यूटेड या क्लाइंट सर्वर कंप्यूटिंग एनवायरनमेंट में आप कैसे यूज कर सकते हो. सो लेट्स इमेजिन ए सिंपल सिनेरियो, बॉयज एंड गर्ल्स. सो इमेजिन आई हैव ए सिंपल लोकल एरिया नेटवर्क. एक लोकल एरिया नेटवर्क है, ए डिस्ट्रीब्यूटेड एनवायरनमेंट है. So this is some cable you can imagine. And you can also imagine, for example, these are some client machines. I have one client machine here, another one here, another one here, and so on. And on this server machine, and this network, we have a huge, big, what do you say, a server machine. You can imagine this is a server machine. Visualize this scenario. This server machine is a very huge hard disk drive, and on which we are implementing a sort of database server, DBS. We are having a database server, and the database is on this hard disk. The job of this database service is to provide requests coming from the clients in terms of queries, in terms of data need from the database, whatever. So different users may be on these different clients. This client 1, client 2, client 3, client 4, and client n. N clients. Thousands of clients may be there. So it is quite possible that the several clients may concurrently send a request for servicing for some database query या फिर database application जो भी हो. So request will call, this is the request queue, boys and girls, this is a request queue. So requests can come, thousands of requests or lakhs of requests may come, some K requests have come together. K may be 1,000, K may be 10,000, K may be 1 lakh, right? लेकिन every day the server, जो server implement होता है client server environment में as a process, as a daemon, it will have some limitation on the number of requests that it can satisfy. Please keep this point in mind कि जो servers आप design करते हो client server environment में, that will have some limitation on the number of concurrent requests that it can satisfy to bear the load. तो यहाँ पर let's imagine this database server has been designed to satisfy not more than 1,000 requests at a time. Let's say it cannot satisfy more than 1,000 requests concurrently together at the same time. These can be lakhs of requests. So out of lakhs of requests, आपने allow करना है सिर्फ 1,000 at a time. तो आप ये कैसे करोगे? This can be very well done by using the principle of counting semaphore. कैसे? I will have to define, listen to me. I will have to define a counting semaphore. Let's call it as S, and the initial value of counting semaphore should be 1,000 because you want 1,000 requests. और हमें यहाँ पर enforce करना पड़ेगा any process desiring to enter the database or enter the system will have to perform a down operation on S. If successful, enter. And after completing the request, it will have to perform up operation on S. And I'm very sure by means of this example, you might have realized the importance of the initial value of semaphore. The initial value of semaphore has to be 1,000. अब जब आप चाह रहे हो कि 1,000 requests can go, you are controlling it. You are putting a control here. You are putting like a filter here. So this filter will not allow more than 1,000 process requests to penetrate into the database. That's how we can use. अगर आप चाह रहे हो कि only 100 processes should enter, you change the value to 100. It will allow only 100 successful requests to go into database. और जैसे ही database से request satisfy हो जाएगी, that process will perform up operation on S, and thereby it will allow another process request. So at a time, not more than 1,000 or 100 requests can penetrate, can be floating in the database. So this is a very clear application जहां पर you signify the concept of initial value of semaphore. तो मैंने कहा था पिछले क्लास में भी कि initial value of semaphore is governed by the application. एप्लीकेशन डिमांड करेगी कि आपने क्या इनिशियलाइज करना है सेमाफोर. अगर आप सॉल्व कर रहे हो क्रिटिकल सेक्शन प्रॉब्लम, तो वैल्यू ऑफ काउंटिंग और बाइनरी सेमाफोर बोथ शुड बी इनिशियलाइज्ड टू 1. अगर आप सॉल्व कर रहे हो क्लाइंट सर्वर एनवायरनमेंट का प्रॉब्लम, काउंटिंग सेमाफोर की वैल्यू शुड बी इनिशियलाइज्ड टू द कंकरेंस मैक्सिमम कंकरेंसी लेवल. Maximum concurrency level is 1,000, so value of semaphore should be initialized to 1,000. That's how the value of initial semaphore or initial value of semaphore is decided, governed by the application. Application हमें decide करवाएगा कि what must be the initial value of semaphore. Hope the point is clear. So that's how the applications of semaphore. So now boys and girls, be ready to start the discussion on very important topic as far as GATE exam is concerned, जिसका नाम है classical IPC problems through semaphores. तो चलिए start करेंगे. सबसे पहला जो प्रॉब्लम हम डिस्कस करने वाले हैं, so let me write the title. I will write it like classical IPC problems. So this is our heading, boys and girls. Solving classical IPC problems through semaphores. The very first problem that we take on for discussion is a very, very important problem based on which we have many real life situations or real life case studies, and that is called producer consumer problem. See this code very carefully because there were many questions asked in earlier papers of GATE PYQs based on this producer consumer problem. Based on this producer consumer problem, काफी क्वेश्चंस आ चुके हैं प्रीवियस पेपर्स में, PYQs में, और फ्यूचर में भी आप एक्सपेक्ट कर सकते हो, So boys and girls, I'm going to show you the implementation of producer consumer problem which will be free from deadlock, which will be free from inconsistency using semaphores. हमने पिछले क्लासेस में देखा था कि how inconsistency can happen in producer consumer problem, how can a deadlock happen in producer consumer problem using sleep and wake up. तो प्रीवियस जो दो इंप्लीमेंटेशन थे, they were bound to suffer from the problem of inconsistency and deadlock. So those two problems can be overcome with our solution using counting and binary semaphore. कैसे देखते हैं यहाँ पर, तो सुनिएगा. So recollecting, एक बार आपको recollect करवा दूं as a summary what is producer consumer problem. एक बार recollect कर लेते हैं. So there are two types of processes, one by name producer, another by name consumer, and they are accessing a shared resource by name buffer, a bounded buffer. Buffer is nothing but an array. This is buffer. Let's say the size of the buffer is n. The size of the buffer is n. That means there are n slots in the buffer. There are n slots. These are the slots of the buffer, sequentially numbered from 0, 1, 2 up to n minus 1. Some n minus 1. Capacity size is n, so n minus 1. This is called bounded buffer. So this is producer process, this consumer process. And let's imagine, for example, okay, this is the variable index in, जो point करेगा next free slot पे. So imagine, for example, there are two items already in the buffer. So the next free slot is 2. So index in will be 2. And out will be basically pointing to the value of the slot जहां से consumer ने consume करना है. So we start consuming from a slot 0. So out is initially pointing to 0. So हमने क्या कहा था, producer इसकी जो life cycle है, first step is producer will produce the data item जो भी उसे insert करना है buffer में. Second step, it will check whether buffer is full or not. अगर buffer full हो तो wait करेगा. अगर buffer full ना हो, then basically it can go ahead with placing the data item in the next free slot. फिर उसके बाद it will go for the next cycle, producing, checking buffer is full or not. If the buffer is full, wait. If the buffer is not full, it will place the item and go. So this is a continuous life cycle, infinite life cycle of producer. उसी तरह consumer की जो life cycle है, first step, consumer will check whether buffer is empty or not. अगर buffer empty हो तो consumer has to wait. अगर buffer empty ना हो, then consumer doesn't need to wait. It will consume the data item pointed by variable out, and then it will increment out, and then it will basically process the data item, और उसके बाद it will go back in the cycle and consume the next data item. ये है consumer की life cycle. So boys and girls, we are required to implement the synchronization requirements of producer consumer problem. तो आप पूछ सकते हो, सर synchronization requirements क्या है producer consumer problem के? So remember, there are 5 total synchronization requirements to be satisfied in producer consumer 5. कौन से है? Let us see. Number 1, producer has to wait when buffer is full. Number 2, consumer has to wait when buffer is empty. Number 3, producer has to wake up consumer if consumer is sleeping. Number 4, consumer has to wake up producer if producer is sleeping. Number 5, last, buffer is critical section between producer and consumer. मतलब अगर producer is accessing buffer, consumer should not be allowed, and vice versa. So buffer is critical section between producer and consumer. Yes, Rishi, that is correct. If buffer is empty, consumer has to wait. If buffer is full, producer has to wait. और जब producer wait कर रहा हो, तो it is the responsibility of consumer to wake up the producer whenever it is sleeping. Likewise, it is the responsibility of producer to wake up the consumer whenever it is sleeping. So बच्चों ये है 5 synchronization requirements which are to be satisfied, which are to be guaranteed by means of semaphore. तो ये कैसे satisfy होंगे? Beautiful application है. Let's try to understand the code. So please follow it carefully. It is very interesting. तो यहां पर हम पहले डेटा स्ट्रक्चर्स डिफाइन कर लेते हैं, फिर उसके बाद कोड लिखने की कोशिश करेंगे. So let me draw the line. And then I will first define the data structures. So let's imagine I define the size of buffer n as some value, maybe 100, 200 slots. ठीक है. We will consider buffer as integer buffer. मतलब जो हम data items की बात कर रहे हैं, those data items are nothing but integer values. So int buffer of n. int buffer of n. अब यहां पर देखिएगा का सेमाफोर्स यूज होंगे. फर्स्ट सेमाफोर दैट वी यूज इज काउंटिंग सेमाफोर. देखिए मैं अपने टर्मिनोलॉजी में लिख रहा हूं, अपने एक नोटेशन में लिख रहा हूं. इट इज नॉट देयर इन द टेक्स्ट बुक. टेक्स्ट बुक में कुछ और तरीके से डिफाइन किया जाएगा. जिस आप ये जो CSEM लिखने से मतलब ये है कि इट इज अ काउंटिंग सेमाफोर दैट विल फैसिलिटेट यू फॉर बेटर अंडरस्टैंडिंग. काउंटिंग सेमाफोर. आई एम डिफाइनिंग अ काउंटिंग सेमाफोर बाय नेम empty. And empty will be initialized to n. ठीक है. What does this empty indicate? यहां पर हम डिफाइन कर लेते हैं. This empty indicate the number of empty slots. Where? In buffer, naturally. Buffer में कितने empty slots है? Will always be indicated by semaphore, counting semaphore by name empty. तो अब सुनिएगा. Initially buffer is empty. सबसे पहले buffer empty होगा. तो what will be the value of empty? Empty will be n. अगर buffer full हो, बफर में कोई empty slot available ना हो, तब value of empty will be 0. Again I am repeating, if buffer is empty, बफर में कोई slot is not occupied with any data item. If buffer is totally empty, then empty will be n. If buffer is full, अगर buffer full हो, there are no empty slots, so empty will become 0. ये आपने याद रखना है, बहुत ज्यादा इंपॉर्टेंट है. Then I will use another counting semaphore. Let us say counting semaphore by name full, initialized to 0. What does full indicate? Let us see. What does full indicate? The value of full indicate the number of full slots. Number of full slots मतलब number of data items. जो वो slots जिसमें data items से भरे हुए हैं, वो slots. So naturally it indicates the number of data items indirectly. So if the value, listen to me, if the value of full is 0, buffer is empty, there are no data items. If the value of full is 0, there are no items, buffer is empty. And if the value of full is n, buffer is full. Full is equal to n. There are n slots filled up with data items, so buffer is full. So full and empty essentially will indicate the status of the buffer. फिर से एक बार repeat कर रहा हूं. If empty is n, full will be 0. और उसी तरह if empty becomes 0, full will become n. That is very obvious. If empty is 0, full will become n. So it means at any point of time, empty plus full will always be equal to n. Am I right? Empty plus full will always be equal to n. यहां पर मुझे आपको कहना है, आपको बताना है कि empty and full ये जो दो semaphores है, this will be used to implement the 4 of the 5 synchronization requirements. 4 of the 5 synchronization requirements. कौन से? To check whether buffer is full or not, to check whether buffer is empty or not, to wake up producer, to wake up consumer. ये 4 requirements fulfill कर पाएंगे हम by means of these 2 semaphores. सर कैसे? वो थोड़ी देर में देखेंगे. फिर लास्ट जो synchronization requirement है जो हमें implement करना है, वो है to treat buffer as critical section, that is never allow producer and consumer to access buffer as treat buffer as critical section, never allow producer and consumer to access buffer together. उसके लिए हमें एक बाइनरी सेमाफोर यूज करना पड़ेगा. सो यहां पर हम डिफाइन करते हैं BSEM का मतलब है बाइनरी सेमाफोर. लेट अस नेम इट एज म्यूटेक्स. इनिशियलाइज टू 1. कमेंट भी लिख दूंगा यहां पर आपके कन्वीनियंस के लिए. दिस इज यूज्ड बाय प्रोड्यूसर एंड कंज्यूमर टू एक्सेस buffer as critical section. ये है data structures. These are the data structures to be used in the implementation of producer consumer problem. सुन लीजिएगा एक बार, देख लीजिएगा. This is a problem definition. and these are the data structures. So in respect of this problem definition and the data structures, we are ready to code the procedure of producer. Producer का code हम लिख सकते हैं now. So please follow me carefully so that you can write. मैं producer का code लिखूंगा, आपको थोड़ा टाइम दूंगा, आप कंज्यूमर का कोड लिखने का ट्राई कीजिएगा. Sujay, hello, very good. Good afternoon. So boys and girls, here I'm trying to write the code of producer. Please check, it is very interesting. Why producer? So here I would like to assume that basically you are quite familiar with C-like language, क्योंकि मैं यहाँ पर assume तो नहीं करूंगा कि this is a C program, but essentially we are borrowing the syntax of C to understand the code of producer. So I will first define a variable called item P, local variable by name item P. In this variable, producer will produce the data item. Producer will produce the data item. फिर एक और वेरिएबल होगा जिसका नाम है इंडेक्स इन, जहां पर हमने डायग्राम में लिखा है, देखिएगा. We are having a variable by name in, right? It will be initialized to 0 that indicate the next free slot. तो start होगा 0 से, आप फिलअप करना शुरू करोगे slot 0 से. Initially in will be 0. So variable in will be used only by producer, it will not used by consumer, इसलिए हमने local define किया. These are all global. ये जो data structure है global है, used by both producer and consumer, लेकिन ये जो है this will be used only by producer. Now by means of this, how do you write the code of producers? Check while of 1. While of 1. Statement 1. What will producer do? First, producer will check whether buffer is full or not. पहले producer will produce the data item. So for that I will write the piece of code like item P. क्योंकि item P में produce करेगा, so we will have a library procedure, imagine, like produce item. So we will imagine in our compiler library we will have a procedure by name produce item. जैसे ही हम उसे कॉल करोगे, it will return a data item and we store that data item in the variable item P. इस स्टेटमेंट के बाद हम अज्यूम करेंगे कि we are ready with data item. We are ready with data item. तो अब producer is ready with data item, it has to check whether buffer is full or not. तो हम कैसे चेक करेंगे? So here we have to basically use the philosophy of down operation, क्योंकि डाउन ऑपरेशन परफॉर्म करने से प्रोसेस ब्लॉक हो सकता है और हमें यहां पर प्रोड्यूसर को ब्लॉक करना होगा व्हेन बफर इज फुल. सो डाउन ऑपरेशन ऑन विच सेमाफोर? वो सेमाफोर होना चाहिए सच दैट इट शुड बिकम नेगेटिव, बिकॉज काउंटिंग सेमाफोर में प्रोसेस वैल्यू प्रोसेस ब्लॉक कब होगा? व्हेन द वैल्यू ऑफ सेमाफोर बिकम नेगेटिव. तो विच सेमाफोर, एम्प्टी और फुल में से कौन सा सेमाफोर विल बिकम नेगेटिव व्हेन बफर इज फुल? तो चलिए अंडरस्टैंड करते हैं. व्हेन बफर इज फुल हमने कहा एम्प्टी विल बी 0. When buffer is full, empty will be 0 because empty indicates the number of empty slots. तो buffer अगर full होगा तो empty की वैल्यू 0 होगी. अगर आप down और empty करोगे तो empty from 0 it will become -1 and it will become negative. That is unsuccessful. और वही केस है. तो इसलिए यहां पर आएगा ऑपरेशन down of empty. Down of empty. सुनिएगा फिर से. If buffer is full, फिर से रिपीट कर रहा हूं. If buffer is full, empty is 0. So down on empty will make empty -1 and block. If empty is not 0, matlab there are empty slots, matlab producer should not get blocked, so it won't be getting blocked. That's a simple philosophy. That's a simple philosophy. So producer has checked whether the buffer is full or not. अब buffer full होने के बाद next producer will have to check buffer is in use or not. Is the buffer in use or not? अगर buffer use में हो तो critical mutex की value 0 होगी. अगर mutex की value 1 है मतलब buffer is free. So it has to perform a down operation on mutex. Down operation on mutex. This will allow the producer to check whether buffer is in use or not. If buffer is in use, get blocked. If buffer is free, access it. तो ये हो गया है बच्चों हमारा critical section. Sorry, entry section. This is the code of entry section of producer. If I am successful in both the operations, it implies that the producer can go to critical section. So it will place the data item in the buffer. उसके लिए हम यहाँ पर statement लिखेंगे in buffer index stat variable in. आपने item p store करना है. You are going to place the data item, and then subsequently you will increment the value of in. In is equal to in plus 1 modulo n. So this will become like your critical section code. ये आपका critical section code की तरह है. Right? This is your critical section. And then eventually when you come out from critical section, critical section से बाहर आने के बाद क्या करना है? सबसे पहले क्रिटिकल सेक्शन को आपने छोड़ देना है। Okay, Sri Harsha is asking for algorithms. Yeah, I would also like to reciprocate. Definitely we'll start Sri Harsha. Operating system का we'll try to close operating system because playlist already 15 lectures तक हो चुकी है, तो remaining part भी हम complete कर लेते हैं, फिर उसके बाद I will immediately start algorithms. Is it okay? I think it's okay. Let me complete because इसे छोड़ दे, बीच में नहीं छोड़ सकते ऑपरेटिंग सिस्टम को, पूरा कंप्लीट कर लेंगे. We'll try to complete this within this month itself ऑपरेटिंग सिस्टम, और उसके इमीडिएट बाद हो सकता है लास्ट वीक ऑफ दिस मंथ इटसेल्फ we will start algorithms. ठीक है. So then after how do you release the critical section? डाउन ऑफ म्यूटेक्स से आप एंटर करोगे, अप ऑन म्यूटेक्स से आप क्रिटिकल सेक्शन रिलीज कर दोगे. So therefore we'll perform up of mutex. And then eventually you will have to wake up the consumer process if it is sleeping. हमने यहां पर देखिएगा, डाउन ऑफ एम्प्टी से एम्प्टी की वैल्यू डिक्रीमेंट होगी, अपॉन फुल से वैल्यू ऑफ एम्प्टी इंक्रीमेंट होगी. तो फुल की वैल्यू इंक्रीमेंट करना है, क्यों? बिकॉज द वैल्यू ऑफ वन ऑफ द स्लॉट हैज बीन फिल्ड अप, तो फुल की वैल्यू इंक्रीमेंट करना है. तो हाउ डू वी बेसिकली इंक्रीमेंट द वैल्यू ऑफ फुल? We increment the value of full by using up operation. So we write here up on full. We cannot increment by saying full is equal to full plus 1, because full is semaphore, it is not an integer variable where you can increment. So boys and girls, this is the code of producer process using counting and binary semaphore. So this is your exit section, this is your enter. So this is your entry, this is your exit. So this is the code of producer process. Sandeep Paul is saying if you interchange down of mutex and down of empty, then it is possible for deadlock. Absolutely correct, Sandeep. अगर ये दो स्टेटमेंट्स को इंटरचेंज करो, अगर बफर की वैल्यू फुल हो, दैट मीन्स इफ देयर आर नो एम्प्टी स्लॉट्स, देन अगर आप इंटरचेंज कर दोगे दो स्टेटमेंट्स को, तो डेडलॉक जरूर होगा. डेडलॉक विल डेफिनेटली हैपन. सो दिस इज अ कोड ऑफ प्रोड्यूसर. तो मैं चाहूंगा 2 मिनट के लिए और 1 मिनट के लिए looking into the code of producer, why don't you try writing the code of consumer? कंज्यूमर में फर्स्ट स्टेप क्या होगा, सेकंड स्टेप क्या होगा, थर्ड स्टेप क्या होगा? आपको कहना है बच्चों, ये जो मॉडल है प्रोड्यूसर कंज्यूमर का, बेस्ड ऑन दिस मॉडल आई हैव सीन इन PYQs प्रीवियस ईयर क्वेश्चंस, different modalities of the producer consumer question asked at least 4 to 5 times. At least 4 to 5 times MCQ questions were asked based on this model of producer consumer. So that's why I always tell my students that this is super duper important topic, जहां पर सिंक्रोनाइजेशन रिक्वायरमेंट्स अंडरस्टैंड करना है, कैसे प्रोड्यूसर वेट कर रहा है, कैसे प्रोड्यूसर ब्लॉक हो रहा है, कैसे प्रोड्यूसर वेकअप हो रहा है, कैसे प्रोड्यूसर बफर को एक्सेस कर रहा है. मीटिंग इन शॉर्ट 5 सिंक्रोनाइजेशन रिक्वायरमेंट्स, हाउ इज इट बीइंग डन, आपने अंडरस्टैंड करना है. एंड देन यू कैन सी दोस 4-5 क्वेश्चंस व्हिच आई वाज टॉकिंग अबाउट, हाउ दे वर आस्क्ड इन PYQs based on producer consumer implementation. So my dear students, try writing or think at least what should be the logic, what should be the code of consumer process. Come on, just a minute of time, think for a minute, and then let me know what should be the code of consumer process. Any idea? Any idea as to what should be the code of consumer process? फर्स्ट स्टेटमेंट क्या होगा, सेकंड स्टेटमेंट क्या होगा? पहले एक बार आइटरेशंस कर लेंगे. नंबर 1, फर्स्ट स्टेप, कंज्यूमर ने चेक करना होगा पहले, सबसे पहले वेदर बफर इज एम्प्टी और नॉट. अगर बफर एम्प्टी हो तो इट शुड गेट ब्लॉक, अगर बफर एम्प्टी ना हो देन इट कैन प्रोसीड. ठीक है. एंड देन सब्सिक्वेंटली अगर बफर एम्प्टी ना हो, देयर आर सम आइटम्स इन द बफर, इट शुड कंज्यूम एन आइटम पॉइंटेड बाय आउट, इंक्रीमेंट आउट, एंड देन फाइनली it should try to wake up the producer if it is sleeping. अगर producer sleep कर रहा है तो it has to give a wake up signal. बस यही implementation है consumer का. So next page we will try to write the code of consumer. Please have a look. I'm writing the code of consumer. So here I say void consumer because it does not return any value and does not accept any argument. So therefore void. जिस तरह प्रोड्यूसर में हमने वेरिएबल आइटम P डिफाइन किया था, उसी तरह यहां पर एक लोकल वेरिएबल डिफाइन कर लेते हैं जिसका नाम होगा आइटम C, एंड ऑल्सो वेरिएबल आउट इनिशियलाइज टू 0. देखिएगा उसी तरह There I have item P and in is equal to 0. Here I say item C out equal to 0 and the life cycle is infinite. So हम while loop use करेंगे while of 1 repeating forever. First step. अब यहां पर हमने कहा produce consumer will have to check whether buffer is empty or not. अगर empty होगा तो ब्लॉक होना है, empty ना होगा तो ब्लॉक नहीं होना है. उसके लिए हमें फिर semaphore operation use करना पड़ेगा. So we'll say like consumer, like producer, we have set down of empty. We have set down of empty. तो यहां पर भी हम उसी तरह लेंगे. यहां पर देखिएगा, I will write the down only because following the same semantics. So down of, now earlier we said empty. जब buffer empty होगा, listen, when the buffer is empty, the value of empty will be 0. Check. When the buffer is full, empty will be 0 and full will be n. When buffer is empty will be n, full will be 0. तो कौन सा semaphore full, कौन सा semaphore 0 है when buffer is empty? Full. So down on full equal to 0 will make full -1 and the process will get blocked. तो हमें यहां पर परफॉर्म करना होगा down on full. So if full is 0, buffer is empty, full become -1, block. चलिए next. Otherwise if full is not 0, mean there are some items in the buffer. So therefore consumer can go ahead with consuming the data item. तो हमें क्या करना होगा यहाँ पर, it can go into the buffer, लेकिन buffer में जाने से पहले it will have to ascertain that critical section is free. So for that it will perform down of mutex. Then it will go to critical section. So this is your remember, this is your entry section code for consumer. फिर उसके बाद यहाँ पर आप consume करोगे item in the variable item C. Item C is equal to buffer of out. ठीक है? And then you will increment the value of out by 1. So this is like your critical section. Out plus 1 modulo n. Circular buffer है, that's why modulo n. And then you have exit section. So exit section में you will first release the mutex, releasing the critical section. So upon mutex, and then eventually you will perform upon empty because one slot has been empty. Down of full will decrement full by 1 और empty की value increment होना पड़ेगा because empty plus full is always equal to n. So therefore you will say upon empty. फिर उसके बाद एक और स्टेटमेंट आप लिखेंगे नॉन क्रिटिकल सेक्शन का, जहां पर आपने इंक्रीमेंट करना होगा. आई मीन यू नीड टू प्रोसेस द डेटा आइटम जो अभी आपने कंज्यूम किया. सो फॉर दैट वी विल जस्ट से ए लाइब्रेरी प्रोसीजर. नॉन क्रिटिकल सेक्शन का प्रोसीजर है प्रोसेस आइटम and then you are going to process the consumed item C. So boys and girls, this is the implementation of consumer process. So this is the exit section. So this is the correct implementation of producer and now consumer. So this solution will guarantee that this will never have any problem of inconsistency. So therefore this will not have any inconsistency, no inconsistency, and it will be guaranteeing deadlock freedom. So therefore this is one of the correct implementation. लेकिन गेट के में एक क्वेश्चन पूछा गया था जो ऑलरेडी ऋषि ने पूछा था कि if you interchange the statements like in consumer process, listen to me boys and girls, by mistake or by chance, for example, by chance if we say that these two statements of consumer are interchanged, you are swapping it, तो क्या होगा? It's very simple. If you interchange these two statements, the down of mutex you write first and down on full you write next, thinking that nothing would happen, लेकिन प्रॉब्लम होगा. कैसे होगा? एक सिंपल सिनेरियो अज्यूम करते हैं. We'll assume a simple scenario to prove how problem can arise. So I will imagine a situation like this. The initial value of mutex will be 1 and the initial value of empty is equal to n and the initial value of full will be equal to 0. Suppose if you start the code with consumer process, I am demonstrating how deadlock may happen. If you start the code with consumer process, listen, if you start with consumer process, तो क्या होगा? Consumer will start with interchange statement down of mutex success because mutex is 1, so value of mutex becomes 0. फिर उसके बाद क्या करोगे आप? down on full, because we have interchange, down on full. Full is 0, so full become -1, and therefore consumer get blocked. Consumer get blocked. On what condition consumer has got blocked? Consumer got blocked on empty buffer. Consumer got blocked on empty buffer condition. But the mistake consumer has done is it has locked mutex. This is a mistake. The mistake consumer has done, it has locked mutex. Buffer is empty, so it got blocked on empty buffer. लेकिन mistake उसकी ये है कि it has basically locked the semaphore mutex. Now imagine producer take the charge. तो producer क्या करेगा? Suppose if it is performing, यहाँ पर देखिएगा code producer का. The code of producer is regular, no interchange, down of empty. So it will perform down of empty. What is the value of empty? Empty is and it will be successful. It doesn't get blocked. It will be successful. Then producer perform down of mutex. ये है problem. Down of mutex, because mutex is 0, so therefore producer get blocked. Now check, both the processes are blocked. Producer got blocked on non-accessibility of critical section and consumer got blocked on empty buffer condition. ये दोनों अलग-अलग conditions है, right? So that is a mistake that has happened. ये जो mistake है, this is not due to semaphore. बार-बार मैं आपको वही कह रहा हूं, this is not the problem of semaphore. This is the problem of the programmer like you and me, who has written the code of this consumer or producer in a different order. मतलब जो order में होना था these two operations, that is being violated. तो पहले यहां पर down of full आना चाहिए, then down of mutex. ये order में रहेगा, तो this deadlock situation will not arise. That is what I wanted to tell. ठीक है? So if you have in this order down on full, यहाँ पर block होगा without blocking mutex, without locking mutex. So this is the correct implementation. तो summary कहने की यही है कि when multiple semaphores are used in the application, then the order in which the semaphore operations have to be used is primarily very important. Otherwise, means semaphore operations has to be used, activated in correct order. Otherwise, it will lead to problems like deadlock or inconsistency. वही बात जो हमने कहा था, यहाँ पर हमने proof किया. So boys and girls, this is the implementation of producer-consumer problem using semaphores that guarantee deadlock-free operation and also ensures mutual exclusion on buffer and no inconsistency also. So चलिए, this is first problem. So let's go to the second problem of classical IPC, and that is called dining philosopher problem. A very important problem again, dining philosophers. Dining philosophers. Again, a very important topic. Lot of questions in earlier papers based on this. And I would also like to make a mention to those who are studying operating system for the first time, that dining philosopher problem जो है, that acts as a base or a foundation, for deadlocks. Deadlock का जो concept है, उसका foundation है dining philosopher. So मैं ये चाहता हूं कि every student should follow dining philosopher problem very carefully to understand the philosophy, the concept, the foundations of deadlocks. ठीक है? So let us describe what is dining philosopher problem. Let us give the definition of dining philosopher problem. So people generally say that this is a Chinese problem. That means the evolution started in China and the problem has been formalized as follows. So generally we are having n philosophers. Philosophers are nothing but researchers or scientists. So there are some n philosophers, n researchers, n scientists you can say, and they have been given a problem. उन सभी को एक problem दिया गया है, research problem है, and they have to think about that problem, they have to deliberate about the problem, they have to carry out a research about that problem and come out with a solution. They need to come out with a solution. So generally, let me write it here, n philosophers. and researchers. Sequentially numbered as like P0 to P4, and they are simulated here in operating system as a process. Philosophers are simulated as process or task, or you can say also as a thread. So let's number the philosophers as P0, this P0, this P1, this P2, this P3, this P4. So boys and girls, I am to tell you that these philosophers are given a research problem to think about, deliberate, propose a solution. So they will enter into a room which has got a round table as shown in the diagram. And these are the seats of the philosophers. So they will sit on their respective seat. And then they start deliberating, thinking, discussing about the problem, about the research. Naturally, after thinking for a long time, they are bound to become hungry. So therefore, to satisfy their hunger, there is a food in front of these plates. These are the plates of the philosophers. Plates. So उसमें कुछ food है, and philosopher, whenever he become hungry, he will want to take that food. So the protocol, the etiquette is that there are forks placed between the plates like this. This one fork, this another fork, this another fork. Fork बोलिए आप chopstick है या spoons, whatever you can call. You can number the forks. This fork 0, fork 1, fork 2, fork 3, fork 4. Fork है या spoon है या chopstick है, whatever you call it as. So rule or protocol is, any philosopher who become hungry will make an attempt to take his left fork. Attempt. हम word attempt इसलिए कह रहे हैं कि when philosopher 0 का जो left fork है, it is fork 0. और उसका जो राइट फोर्क है फोर्क 1 है. उसी तरह फॉर फिलोसोफर 4 उसका लेफ्ट फोर्क है फोर्क 4 एंड इसका राइट फोर्क है फोर्क 0. तो कहने का मतलब यह है बच्चों, फोर्क 0 इज शेयरेबल बिटवीन P4 एंड P0. फॉर हिम दिस इज लेफ्ट, फॉर हिम फॉर P4 इट इज राइट. सो फिलोसोफर 0 इफ इट बिकम हंग्री विल मेक हिज अटेम्प्ट टू टेक हिज लेफ्ट फोर्क. तो ऐसा हो सकता है कि फोर्क अवेलेबल हो या ना हो. तो दैट्स व्हाई आई एम यूजिंग द वर्ड philosopher will make an attempt to take the left fork. If successful, he will make an attempt to take the right fork. If successful, then he will eat infinite amount of time. Eat karega, then he will put down the left fork and put down the right fork. After that, he will go back to thinking. ये है life cycle of philosopher. Based on dining philosopher, there were again lots of questions asked in earlier papers. और मैं कह रहा हूं ये फाउंडेशन टॉपिक है. अगर आप डाइनिंग फिलोसोफर का कॉन्सेप्ट सही तरीके से समझोगे तो डेडलॉक के जो कॉन्सेप्चुअल क्वेश्चंस है आपको आसानी होगी सॉल्व करने में. वरना अगर आप डाइनिंग फिलोसोफर प्रॉब्लम सही तरीके से नहीं समझोगे तो डेडलॉक के जो कॉन्सेप्चुअल, रीजनिंग, एनालिटिकल टाइप ऑफ क्वेश्चंस है वो आप सॉल्व नहीं कर सकते. आई हैव सीन दैट फ्रॉम माय प्रीवियस एक्सपीरियंस. सो बॉयज एंड गर्ल्स, प्लीज फॉलो दिस केयरफुली. तो हम क्या करेंगे, बेस्ड ऑन दिस प्रॉब्लम डेफिनेशन वी विल ट्राई टू राइट द कोड ऑफ प्रोड्यूसर प्रोसेस, फिलोसोफर प्रॉब्लम हियर. सो फर्स्ट वी विल डिफाइन द नंबर ऑफ फिलोसोफर्स एज यूजुअल. Define the number of philosophers, some 5, 4, whatever number you take. Minimum value of number of philosophers is 2. Minimum value is 2. I can't have less than 2 philosophers. So therefore define n as 5. And then we will write the code of philosopher in the form of a procedure again, void philosopher. Int I. I indicate the ID number. So this variable I can be either 0 or 1 or 2 or 3 or 4, something like that. I can be either 0 or 1 or 2 or 3 or 4. Then the life cycle is infinite. तो हम यहाँ पर फिर से while loop लेंगे. So while of 1. What will be the first activity of philosopher? जैसे ही philosopher room में आएगा, he will start thinking. So therefore, the first activity is think. Philosopher is thinking. Then after thinking is over, right? When he completes thinking or when he becomes hungry, he will come out from thinking state and will make an attempt to take the left fork. उसके लिए हम imagine करेंगे कि we have a procedure by name take fork in our library. So take fork of I. I is denoting left fork. So let's mark it here. I is denoting left fork. आप नंबरिंग देख सकते हो डायग्राम में, नंबरिंग देख सकते हो. For philosopher 0, left fork is 4. For philosopher 0, left fork is 0. For philosopher 1, left fork is 1. For philosopher 2, left fork is 2. For philosopher I, left fork is I. If philosopher is successful in taking the left fork, then the philosopher can take the right fork. Right fork will be given by the ID I plus 1 modulo n. Modulo n इसीलिए कि philosopher 4 के लिए जो right fork है, philosopher 4 के लिए जो right fork है वो 5 नहीं है, 0 है. So 4 plus 1 5, 5 mod 5 is 0. So that's why you use mod n. So this is your right fork. This is your right fork. This is your right fork. If successful in taking the right fork also, then the philosopher will go to eat. And after eating is over, the philosopher will release the fork. So it will say put fork of I, and then put fork of I plus 1 mod n. Put fork of I plus 1 modulo n. ये है code of as you think based on problem definition. ये basis पर भी PYQs में काफी questions आ चुके हैं using semaphore, using other aspects. So philosopher is initially thinking, if he becomes hungry, come out, take the left fork. If available, come out, take the right fork. If successful, then you go to eat and then release the fork I plus 1 mod n. So when you give a peripheral overview to this code, अगर आप at a glance through आप देखोगे code को, तो आपको लगेगा कि this will guarantee or satisfy all the requirements of dining philosopher. लेकिन हमें जो analyze करना है preemptive environment. अगर आप नॉर्मल सेंस में देखोगे विदाउट प्रीएम्पशन दिस कोड विल वर्क परफेक्टली करेक्ट, लेकिन अगर जब प्रीएम्प्टिव एनवायरनमेंट में एग्जीक्यूट करने की कोशिश करोगे देन कैन देयर बी अ पोटेंशियल पॉसिबिलिटी ऑफ अ डेडलॉक हैपनिंग हियर. क्या डेडलॉक यहां पर हो सकता है? वी हैव टू एनालाइज दैट. सो फॉर दैट वी कैन टेक अ सिंपल सिचुएशन. सो फॉर डेडलॉक टू हैपन द फर्स्ट कंडीशन इज ऑल फिलोसोफर्स शुड बिकम हंग्री. All philosophers to become hungry at same time. This is the first condition for deadlock to happen. तो हमें मानना होगा कि all the philosophers have become hungry together at the same time. Now P0 will start, philosopher 0. So philosopher 0 starts, so he will pick up left fork, let us say fork 0. He pick up the left fork. But before taking the right fork, let us say the philosopher 0 got preempted. Then philosopher 1 will try taking the left fork 1 successful. ये भी preempt हो गया है. That means I am imagining a simple situation that every philosopher became hungry and everyone has taken their left fork, and before taking right they got preempted. Means the situation will be like P0, P1, P2 will take F2, got preempted. P3 taken F3, got preempted. And last P4 has taken the fork F4, got preempted. So everybody has taken their fork, left fork, and got preempted. P0 got F0, P1 got F1, P2 got F2, P3 got F3, P4 got F4. So everybody has taken their left, and now everybody will try taking their right fork. So P0 will try taking right fork. Right fork is already held by P1. So therefore P0 waits on P1. P1 is taken left fork and try for right. Right is taken by P2. P1 waits on P2. P2 waits on P3. P3 waits on P4. P4 waits on P0. So there is a clear cycle among the philosophers. This cycle implies a deadlock situation between the dining philosophers. So this particular code जो हमने देखा यहाँ पर, this code is subjected to suffer from the problem of deadlock. This code of dining philosopher will have the problem of deadlock. So now the question is how to overcome deadlock, how to solve this problem of deadlock. Boys and girls, there are two solutions for solving the problem of deadlock. One is non-semaphore based, and the other is semaphore based. As an application of semaphore, the other solution is semaphore based. Non-semaphore based solution में again there are two approaches. We can say that out of n philosophers, let n minus 1 follow the order left to right and one philosopher break the order right to left. And the other is out of n philosophers, let us say even number follow left to right order and odd number follow right to left order. Right to left का मतलब ये है कि n-1 philosophers will take first left fork and then right, and one philosopher first will take right and then left. So if you follow this, then deadlock will never happen. Sir, आप कैसे prove कर सकते हो कि deadlock will not happen? देखिएगा, दो philosophers का test करेंगे. You are one and I am one, right? So there are two forks, left and right. आपके भी left and right पर है. My left is your right and my right is your left. Suppose if I take my left first, then control is given to you. You have to follow RL because I'm following LR. You have to follow RL. So you take your right, not available, you get blocked. Then I will take my right, I will go to it, put down the fork and continue. So therefore this will guarantee that it will not have any kind of deadlock situation. उसी तरह if you follow even odd number, even philosophers will follow left and right, and odd number will follow right and left. So this will also guarantee that we will not have any deadlock situation with the philosophers if we follow this. This is non-semaphore based solution. The other solution is semaphore based. That is the clear application of semaphore. Semaphore based में ये है कि here if you observe, if you look at the diagram, the shared resource are forks. These are shared resources. So you have to basically put a semaphore control on this. Taking the fork is like increment, putting down the fork is like decrement operation. So taking and putting down the fork, अगर आप semaphore operation के control में रखोगे down and up operation से, then I'm very sure you understand that the problem can be overcome. तो ये जो solution है using semaphore control, it is given in the textbook of Galvin. जिस तरह हमने code producer consumer का लिखा, उसी तरह code आप understand कर सकते हो. The logic of it, the crux logic of it, I'm telling you. Fork is critical section. So the operations, fork are critical resources. So the operations take fork and put fork, you have to put semaphore control. So any philosopher trying to take the fork or release the fork should be done in a mutually exclusive fashion. Then my problem can be solved. So that is what is the problem solution given in the textbook of Galvin and also in the textbook of Tannenbaum. You can have a look at it as we did the solution for producer-consumer problem, and you can see how it overcomes deadlock. So semaphore-based solution will also prevent deadlock happening in dining philosopher quiz. So in today's session, these are the two problems that I intended to work out. One was producer-consumer, where we have seen how semaphore can come to our rescue, solving the problem of critical section, meeting the synchronization requirements of full buffer, empty buffer condition, causing the producer and consumer to wait when buffer is full and buffer is empty, and waking up respectively each other. And subsequently, producer-consumer problem, how deadlock can happen and how deadlock can be prevented as semaphore-based solution and non-semaphore-based solutions. So that is the intention of today's lecture. Next session में हम continue करेंगे synchronization का, और we will start with deadlock chapter. यहाँ पर हम देखेंगे conceptualization of deadlock, necessary conditions for deadlock, characteristics of deadlock, and then essentially the deadlock handling strategies. ठीक है? So till that time, take care, continue your learning journey, and happy weekend. Thank you.